Hi, my name's Thomas Macaulay. I'm second officer here on board the Pride of Hull, and I work for P&O Ferries. My responsibilities here on the Pride of Hull are a navigation officer, and in that role I drive the ship from point A to point B, and also I'm responsible for the loading of the cargo down on the vehicle decks. Maths is a really important part of my job here on the bridge, particularly in terms of navigation. We use it on a daily basis. As a result of that, you have to have a minimum grade of C at least at GCSE level in order to gain entry into the apprenticeship. Some companies, however, require A-level maths, and there are even instances of people entering into the apprenticeship with degree-level maths. One of the really important ways that we can use maths on board the ship is to calculate the distance of the visible horizon. This circle here represents the Earth, and this dot here is the centre of the Earth. I can then draw on the picture where my location is, and this cross represents the height of the bridge above the sea. I can then draw two lines from this cross. One, two, and these two lines represent the visible distance of the horizon. You can then label the points A, B and C. Okay, I'm going to draw some more lines on now. First of all, I'm going to draw a line from my position to the centre of the Earth and label this point, point D. This distance here represents my height of I, which is 39 metres, and this distance here, D, to the centre of the Earth, which is the origin, represents the radius of the Earth. And then I'm going to draw some more lines here and here, and these two lines also represent the radius of the planet Earth. Okay, the two lines that represent our visible horizon are actually also what we call tangents, and we know from our circle theorem that a tangent is always at 90 degrees to the centre of a circle when it hits the edge of a circle. You can therefore say that this point here and this angle here are at 90 degrees. Now the object of the exercise is to calculate obviously the distance of the visible horizon. To do that, I can use this distance here, which I know to be 39 metres, and this distance here, which is a fixed and is the distance from the centre of the Earth to the outer edge of the Earth, the radius of the Earth. And therefore I can use this, which is a right-angled triangle, and also Pythagoras' theorem, to calculate the distance AB. This distance can vary considerably depending on the size of ship you're on. For example, the Pride of Hull is a very large vessel, and so the visible horizon will be greater than that on a smaller vessel such as a yacht.